Take a look at problem 1813. An organ pipe open at both ends is 1.5 meters long. A second organ pipe that is closed at one end and open at the other is 0.75 meters long. The speed of sound in the room is 330 meters per second. What of the following sets of frequencies consists of frequencies which can be produced by both pipes? Let's take a look at the first situation. We've got an open end pipe. So the standing waves are constrained to have an antinode at either open end, and maybe some nodes in between, but ultimately we are going to have standing waves such that we have maximum amplitude at either end. The length of this pipe is 1.5 meters. And this kind of situation where we have the same kind of node, or in this case antinode, at either end is similar to that which occurs for a fixed string which has a node at either end. In other words, the harmonics are going to be equal to n over 2L times the velocity of waves on this medium. In this case, it's the velocity of sound. And n is just an integer, 1, 2, 3, 4, and so forth. Okay, so this is the equation that would give us the resonant frequencies for this situation. Let's take a look at the other pipe. We've got a closed end, open end pipe. So we're going to have an antinode at the open end, a node at the closed end, and so I might have something that looks like this. And the length of this is 0.75 meters. Now in this case, our fundamental is just going to be a quarter wavelength, and in fact, our harmonics are going to be equal to n over 4L times the velocity of waves. In this case, our n's, let's call them n2, are going to be odd integers. So only the odd harmonics are going to survive. So these are the possible resonant frequencies that we can have in these two tubes. Now if we look at the fundamental, say for the open end tube, the fundamental will be 1 over 2L times the velocity of sound. So that's going to be 1 over 2 times 1.5 times 330, which was given for the velocity of sound. So that is going to be 330 divided by 3, or 110 hertz. All of our frequencies after that are going to be n times that fundamental. So we are going to have possible 110, 220, 330, and so forth and so on hertz. For the closed end open end pipe, our fundamental is 1 over 4L times the velocity of sound. In this case, that's 1 over 4 times 0.75 times 330, which is also 110 hertz. However, our harmonics are, let's use N2 here, odd harmonics. So we can have a possible 110, or 3 times that, which would be 330, or 5 times that, 550, or 7 times that, 770, and so forth hertz. So the harmonics that would be common to both of these situations would be 110, 330, and then 550 if we had gone so high with the open end pipe. So those harmonics will be in both situations. Answer C, because that's the only situation that contains these three harmonics. The odd harmonics are the ones that both of them will have.